una bozza. Ukimuana, ana inama, ana inuka, ana haya.
Hi everybody, welcome. My name is Eduardo and you are welcome to this session of conditional probability and magic. For this session you will need 4 cards, so like piece of papers like this, with one side left blank and the other one colored of one color, and you should color 2 cards of one color and the other 2 cards with another color. Then you need 1 pen and 1 sheet of paper in order to take some notes. Okay, so I have prepared my 4 cards. Now I shuffle them, and now I ask you, what color is on the other side of this card? So for you this is a difficult question. This card can be any color. It can be yellow, green, blue, red, black. But for me it is a bit easier because I made these cards and I know that I colored them either blue or red. For example, I already know that this card cannot be yellow or green or black. This is the central point of conditional probability. It allows you to guess on something based on some prior knowledge on the problem that you are facing at that point. Conditional probability is everywhere, and we use it every time we have hints on something that we have to guess. In order to realize this, let's play a very simple and fun game. The facilitator will think about one of you learners, and each group of 2 learners in the classroom will try to guess which learner is the facilitator thinking about. And each group will write this guess on their sheet of paper. Then the facilitator will give you 3 hints about the learner he or she is thinking about. And after having heard these 3 hints, it can be, for example, whether the learner is wearing a shirt of a certain color, or if the learner is tall or short, male or female, something like that. And after having heard these hints, each group has to guess again. Finally, the facilitator collects on the board all of your guesses before the hint and all of your guesses after the hint. And you will count how many right guesses there were before the facilitator gave the hint and after the facilitator gave the hint. So probably the number of right guesses was much higher after having given the hints than before. Why? Well, the first time you were trying to guess which learner was it out of the whole classroom. Whereas the second time you had, for example, these 2 guesses. The learner was male and it was tall, so you was choosing at random out of a subset of the classroom, which was much smaller than the classroom itself. In mathematical terms, the first time you were trying to estimate the probability that the facilitator had in mind one learner, whereas the second time you were trying to estimate the probability that the facilitator had in mind one learner, given that the learner was male and tall. This is how a conditional probability is written in mathematics. Let's play a second game. Out of your 4 cards, choose 2 of a color. For us it will be blue, and one of the other color. For us, it will be red. And play with your partner. So, one partner will place the 3 cards covered in whatever order he wants, while the other partner cover his eyes. I show you the cards, and I put it this way. Then the partner uncover his eyes. Be honest. And you make him guess where the red card is.
I have no idea. I would say this one.
Okay. Now, you know which is the red card. And in order to give him a hint, you uncover one of the blue cards. There will be always one blue card to uncover. For example, this one. And now you ask your partner, would you like to change your guess now that you know that this is a blue card?
Yes, why not? I would like to change. I pick this one now.
Wonderful. Take a sheet of paper and write whether the partner has changed his mind or not, and whether the partner has guessed right. In this case, no, he didn't guess right. Actually, he was right the first time. Make a table like this with 4 cases. Here you write has changed mind, hasn't changed mind, and on this side has won, has lost. And each time you play this game, you make a cross corresponding to the 2 conditions that were true. In the example that we've shown, my partner has changed his mind and has lost. So there will be a cross here. Let's play again. Now my partner will choose one of the 3 cards.
I choose this one.
Great! And I, who know where the 2 blue cards are, will uncover one of the 2 blue cards. Now, do you want to change your guess or not?
I don't.
Great. So you will stay with this card. Let's see.
Oh no, it's blue.
Yeah. So again, my partner didn't have any luck. We will put a cross on hasn't changed his mind and has lost. Now, each of you choose a partner and play this game 10 times each. Stop the video now and try it. Okay, now that you have done it, collect all your data together and make a super table just like the one we had here, with all the crosses from all the groups in the classroom. Count them and discuss. Which of the 4 cases has the most crosses? And in your opinion, why? It is once again a matter of how much information you have. The second time, even if no one has told you anything about your choice, you have more information on the problem itself. So, if the first time that you guess, you were guessing at random over 3 cards, the second time, if you guess again, you're guessing on a set of 2 cards. And this is exactly equal to the first case that we saw during this lesson. So we have seen that conditional probability tells you that having more information helps us making more educated guesses on the problem we have. Thank you for joining us for this session, and I hope you enjoy the rest of your virtual math camp. Ciao!